So I love this chapter because I kind of just am able to just code and draw as I code. So it's a very nice change. I don't really have to explain like just without coding, which is fantastic. So let's go ahead and it's just nice building data structures. It's very, they just build themselves as far as once you understand how to do them. So linked lists, we're going to start out with figuring out what variables we need, just like we did for an array list. In fact, this is going to follow a lot of what we had to do for an array list. So first we need a private int size, right? That's straightforward. We need a private int size. This class over here, the static class and the public static void main that we're going to use for testing in here, that's just going to be at the end. Okay, so private int size. And then we're going to do, the other thing we need is that we are going to do this singly linked list. I'm going to code both a singly linked list and a doubly linked list. First, I'm going to do the singly linked list. So private node e head. This is the first item in the list, and really it is the only thing we need to keep track of explicitly. Everything else is going to be kept track of implicitly. Okay. Public void, and let's see, public linked list. The constructor is fairly straightforward. Set the size equal to 0, and set head equal to null. But actually, I could just simply leave it blank and it would do that automatically because those are the default values. I don't need to keep track of anything else. In the doubly linked list, and the circular linked list, I'll have a tail as well, which will keep track explicitly of the last one. But for the simplicity's sake, I'm going to just add complexity to this as we go along from one class to another. So I'm not going to use a tail. Okay. Likewise, we need 4 primary methods to write, plus we'll need the toString and a bunch of other stuff. So again, we're going to start out by adding stuff because we need to be able to print out the linked list in order to see what we've got here. Or we've got to have stuff in the linked list in order to be able to print out and see what we got. So public void add public. Let's go ahead and do this one first. Public Boolean add is going to be the exact same as it is for an array list, by the way. Public Boolean add item. All we're going to do is just simply go back to the other one. So return true. And then this dot add size item. And then just like an array list, right? Int index size e item. Right? Lists have index even if linked lists are scattered around everywhere. So, right, this looks exactly the same over here for a link as it does for an array list. Similarly, public size, public int size looks exactly the same. Return size, right? And we call it size the exact same reason. Okay, so far so good. Let's go ahead and actually taskbar settings automatically hide it. There we go. That looks cleaner. All right. So we've got that. And so there are basically 3 steps we need to do for adding an item at a specific index. 3 cases, if you will. Okay. And that's for a singly linked list. Singly linked lists have 3 cases for add and remove. And doubly linked lists have 5 cases. Well, they have 3 cases so long as you only are keeping track of the head. 5 cases otherwise. And the 3, we're going to start with the 3, and then we're going to go to the 5. And it just so happens that the 5 contains the previous 3. So, it's just 2 more. So there's 3 cases. The first is fairly straightforward. What if the index, so our three cases are index out of bounds, or adding a new head, adding anywhere else. Those are our three cases. Between those three, that should do it. We are able to program the first two pretty quickly. The first one is, guess what? Exactly like an array list. If index is less than 0, or index is greater than size, right, for the same reason for an array list, then we are going to return, we're not going to return, we are going to throw new index out of bounds exception, and we'll just simply say deja vu, because why be useful when we can be funny? You should probably be useful. I'm just going to keep that. Okay. So, deja vu. Now, great. Now I have to look up how to spell it. Not to be confused with deja vu, by the way, the martial arts where you feel like you've been hit that way before. So, anyway, that is our first, exception. In our first case. Bounds. Right? If the index is out of bounds, just, throw a tantrum. So that's done. Let's see. Yeah. Okay, now let's say adding a new head. So what index is adding a head? What is the condition for this? Well, we're adding the head is the first item in the list. So we're saying here, if index is equal to 0, then we need to do something. Do something. And then our last case is else any other case. Now I don't need to do an else if over here, because if this happens, it crashes the program. No need to bother with an else if, right? But if it makes you feel better, it's probably good practice to do an else if. Anyway, I'll go ahead. So let's go ahead and create our example linked list over here. Boom, 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 boom. Right. So I'm going to go ahead and make a linked list with 4 items in it. Let's go ahead and space it out a bit. We're going to take this arrow, point to next, and attach. And we'll use that last arrow at some other point for this other node that we're adding over here. So this guy over here, we need to denote one of these as the head. Right? And I'm just simply going to say, hey, this guy is the head of the list. It's the first item in the list. Makes sense. All right. So in other words, so the question is, how does adding to the head go? Isn't there something we're forgetting? Yes, there is. Size ++. So we will go ahead and look at that conundrum of how to solve it, of how to add something to the head in the next video.